Hello, this is Mrs. Ross, and this is lesson 27, practice set. We're going to be talking about multiples, least common multiple, and equivalent division problems. So let's see, let me go ahead and pick one of these. It says, find the least common multiple of each pair of groups of numbers. So let's see. So when it talks about multiple, I think multiply. And what I'm going to do is I'm going to do 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, 8 times 6, 8 times 7. These are multiples of 8. And then multiples of 10 are 10 times 1, 10 times 2, 10 times 3, 10 times 4, 10 times 5, 10 times 6, 10 times 7, etc. So the smallest multiple that they have in common is 40. So my LCM of 8 and 10 is going to be 40. Let me change colors really quick. All right, let's do 4, 6, and 10. So 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7. Okay. All right, let's do 6. 6 times 1, 6 times 2. You can already see they have those in common. 6 times 3, 6 times 4. They have those in common. 6 times 5. 6 times 6. 6 times 7. Okay, and then 10. 10 times 1, 10 times 2, 10 times 3, 10 times 4, 10 times 5, 10 times 6, 10 times 7. So let's see, it looks like, oh crap, 20, 30, this is ugly. It may be 40. Oh, it can't be 40. Okay, let's keep going. So, because this isn't 20 and that's not 30, so let's see. So this is 4 times 7, 4 times 8, 4 times 9, 4 times 10 is 40. There's 40. It's not 40 because it doesn't work here. Let's see. This is 6 times 7, 6 times 8, 6 times 9. I'm running out of room here. 6 times 9, 54. 6 times 10 is 60. I wonder if 4 will go into 60. Yeah, I just happen to know that 4 will go into 60. I believe it's 60 because 4 times 15 is 60. Now I know that. I mean, I guess you could keep going here. This is 4 times 10, so it would take me 5 more tries to get to 4 times 15. But 60 is going to be your LCM. That one was kind of rough. For 4, 6, 10. All right, let's check out the next one. This says use prime factorization to help you. I don't know about all that business. But I'll prime factor away. 2, 6, 2, 3. So these are all prime. Let's pick a different color. It's not yellow. Okay, so let's see. This is 2 and 20, 2 and 10. These are all prime. This is 2 and 5. So let's see. If I put 24, I have 2 times 2 times 2 times 3. And I have 40. 2 times 2 times 2 times 5. And let's see. I tried this once before, and I think I was doing the LCM. So let's see. These they have in common, so that's 2. These they have in common, so that's 2. These they have in common, so that's 2. Times 3 times 5. So 2 times 2 is 4, times 2 is 8. 8 times 3 is 24. Get the calculator out for 24 times 5. 120. So the LCM of 24 and 40 is 120, and that's how you find it using the prime factorization. Let's do this one. 3 times 10, 2 times 5. End of story. That was really quick. Okay? And then I need another color. Here we go. 75. I'll do 75 over here. So 5 and 25? Is that right? It's late in the day. Nope, that's not right. 75 divided by 5. 15. My bad. This is 15, 3, and 5. So those are all prime. So let's line them up again like we did down here. 30 is going to be 2 times 3 times 5. 75 is going to be 3 times 5 times 5. So I have the 3s and I have the 5s. So I have 2 times 3 times 5 times 5. So that's 2 times 3 is 6, times 5 is 30, times 5 is 150. So my LCM of 30, that's a 3, maybe, and 75 is 150. Next. Okay, so this is where we get into this equivalent division stuff, and they want you to try and do stuff in your head. I'm not 100% fan of doing stuff in your head since you'll always have a calculator with you, but I'll show you how to do it just in case. So it says, instead of dividing 7.5 by 1.5, double each number and mentally calculate the quotient, which is the answer to a division problem. Okay, so if I double this, 2 times 7.5, I'm going to get 15. And if I double this, 2 times 1.5, I get 3. 3 goes into 15 5 times. Okay, let's pick a different color. Mentally calculate each quotient by finding the equivalent division problem. What strategy did you use and why? So this is 24,000 divided by 400. Or I can write it like this. And I can cross out my zeros. So now I have 4 into 240, which is 60. I'm not really sure why that's a strategy. Okay. This is 6 divided by 12, or $6 divided by 12. So I have a decimal here. I would put a decimal here. 12 goes into 65 times. That's how I did it. And then lastly, 5 into 140, I'm not really sure what the deal is. So 5 goes into 14 2 times. And then 5 goes into 48 times. So that's the practice problems. If you have any questions, let me know.